Good day, students. Today we want to solve problem on moment of force and forces, and we need to consider conditions for parallel coplanar forces, conditions for equilibrium of parallel coplanar forces. Now, under forces, it talks about the algebraic sum of the forces acting on a body in any given direction that must be equal to 0. It says that all algebraic sum of the forces acting on a body in any given direction must be equal to 0. You can see it. And it's also saying that the sum of the upward forces, that is, sum of the upward forces must be equal to the sum of the downward forces, or sum of the forces acting in one direction must be equal to sum of the forces acting in the opposite direction. And if you define it with any of the three, you get your full mark. The second conditions for the equilibrium of parallel coplanar forces is on moment of force, which says that the algebraic sum of the moment of forces about any point on a body must be equal to 0, or the sum of the total clockwise moment of a force about a point on a body must be equal to the sum of the anticlockwise moments of the force about the same points. And these second conditions for equilibrium of parallel coplanar forces is referred to as principle of moments. And it states that when the system is in equilibrium, the total sum of clockwise moment of forces, total sum of the clockwise moment of forces is equal to the total sum of the anticlockwise moment of forces about the same points. Please, let's take note. Now, let's see example that we have on the board to analyze the two conditions. From the taking moment about C, let's take moment about C. Take moments of force about C. Now we are now taking from first condition of the equilibrium, which talk about upward force, sum of the upward force equals to sum of the downward forces. Sum of the upward forces, you can see they are plural. The up one, we have two of them, but the one that's coming down, we only have one force. Sum of the upward forces equals sum of the downward forces. But now you now say P plus Q equals to 10 because we only have one force down. Now from there, you can now go, let's go to second condition. From second condition, what do you have? From the second condition, it talks about the total sum of the clockwise moment equal to total sum of the anticlockwise moment about the same point. Now let's see the clock. When you are taking moment about C, the clockwise moment is moving toward the right. You have a 10. That's clockwise moment of force. Now we are taking moment about C. You can see this force Q is coming. That's moving toward the left, anti-clockwise moment of force. Now you now see from second condition, anti-clockwise moment equals to clockwise moment of force. And what's our anticlockwise moment? Q is the force. Q times 6 plus 2, because this is the distance. 6 plus 2 will give us the distance before we get to point C. Now say Q, which is the force, times perpendicular distance. 6 plus 2 is the perpendicular distance, times 2 plus 6 equals, let's go to clockwise moment, 10 times 2. Force times perpendicular distance, 10 times 2. You now have Q times 2 plus the board mass. Solve addition before solve the bracket before the multiplication. You can see board mass. Let's see, solve the bracket. What's in the bracket before multiplication? Is that okay? Because this addition, the two of them are together. That's why I put it in brackets. Now Q times 8 equals 10 times 2. Okay, now 8Q equals to 10 times 2. I leave it like this so that I can divide. It's very easy for me to divide. 8 divided by 8, 2 here 1, 2 here 4, 2 here 2, 2 here 5. 5 over 2 equals 2.5 Newton. Therefore, our Q equals 2.5 Newton. Okay, from the second condition we got this. Now go from first condition. Substitute Q equals 2.5 Newton. Because of that, we now have P plus 2.5 equals 10. Now you collect the like terms. P equals 10 minus 2.5 equals 7.5 Newton. This when you are taking moment about C, but another student can take moment about Q. Let's see what you are going to get. When you take moment about Q, let's put all, taking moment of force about Q, about D, as a pivot. What you need to do is that still the same condition, up some of the upper forces equals some of the downward forces. P plus Q equals 10. Okay, now since you have it like that, now from this one got it from first condition of equilibrium. Now from second condition of equilibrium, what do you have? You take moments about D. Let's see, clockwise moment. Clockwise moment equals anti-clockwise moment. That's the condition. Now let's go to clockwise moment. We are taking about D. This clockwise moment. This force clockwise. Okay. Yeah, clockwise moment. While this force to come to this side as it's moving toward the left, anti-clockwise moment. Now clockwise moment is P, which is the force. P times the distance from here to Q to D. From this P force to D is 2 plus 6 equals S anti-clockwise 10 times 6. 10 times 6 anti-clockwise moment. P times 8 equals 10 times 6. 8P equals 10 times 6 divided by 8, divide both sides by 8, 8 cancel 8, 2 here 4, 2 here 3, 2 here 2, 2 here 5. P equals 15 divided by 2, which was 7.5 Newton. From first condition, which is substitute P equals 7.5 Newton. From there you have 7.5 equals 7.5 plus Q equals 10. Now Q, collect the like term, equals to 10 minus 7.5 equals 2.5 Newton. Okay, you either follow this condition, take moment about C, or take moment about D. You still arrive at the same answer. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.